My name is Peter Schild. I work at Sintef Building and Infrastructure in Norway, and I'm going to demonstrate the use of the spreadsheet called Mini-Balance, which can be used as an aid for balancing ventilation systems on building sites. This is a very simple sheet, and that can be, in principle, used on any smartphone that can open Excel spreadsheets, and can also be used on laptops, etc., on the building site. Of course, use the proportional method of balancing, which means that you use it for balancing AV or air volume air terminals that have to be adjusted and fixed. It's not for adjusting VAV air terminals. So I'll just demonstrate how we use this. I'll open the spreadsheet. The spreadsheet consists of two sheets, or two worksheets. The one that you can see now is called General Input Data, and as you can see, when you move the mouse from cell to cell, you have boxes here, these comment boxes. Maybe I'll just change the zoom so you can see next. And then the second sheet, which is called Balancing, if you move the mouse down to the bottom of the screen, you can see a little tab there. Click on the tab. Now this is the main sheet, which is actually being used for doing the balancing. And as you can see, there are different colors in the columns. Now the green columns, they can be filled beforehand, let's say in the office. The gray columns, there are two gray columns. Now these contain equations, and you shouldn't delete them or cells. So these two columns, they give feedback as you progress in the balancing. And here have some more green columns, measurement units, design, flow rate, etc. per terminal. And then the columns here to the right, these are where you're actually filling in as you start and as you progress in the balancing. And you can move the columns. There are a large number of columns here to the right, so I can actually move to the right of the screen. You can see quite a large number of columns. Now the first column here, first column here is where you start the process, and as you do make adjustments, you progress from column to column. These columns, of course, have help text boxes up here. And of course, there is a user manual you can download from the AAVC website. Now, what I'll be doing now is to demonstrate how we use this spreadsheet. Now we're going to open a simulation tool. Now this is a simulator where we are going to balance a duct which has 5 air terminals. As you can see, there's a person who has a little red box. That's like a measurement instrument, which is measuring the flow rate for each terminal. So I can move this person from terminal to terminal. So now we're going to start balancing. Right, we go back to the spreadsheet. We just make sure we have all the information we need for the general input data, the building, etc. We don't need to fill this out in the demonstration. But we're going to the design flow rate. Say we want design flow rate in terms of cubic meters per hour. You can have different alternatives, but we're going to have it cubic meters per hour. Balancing accuracy, let's say we want 5%. That's very accurate. And there are different languages, so you can choose, let's say this is Czech, number of languages, so we're going to have English. So now we're going to start balancing. So first we do the office work. We're going to fill in the terminals, and the measurement units, we want cubic meters per hour for all of them, so we will do that. And as you can see now, already we are starting to get messages from the two gray columns, and it says design ? That means you want to know what the design flow rate is. And for this terminal, you want, say, 100 cubic meters per hour. And I'm saying you want to measure the initial measurements, but we can't do it until we've actually finished the design flow rate for all the terminals. So we'll do that. do is actually drag cell down there if you have the same number in each. There we go. So now I have 5 terminals, each where we want a design flow rate of 100 cubic meters per hour. So now we can start measuring. So we go to this menu here, and we call them terminal 1 is always the reference terminal, as in the terminal that is furthest away from the fan. So this is terminal 1, terminal 2, terminal 3, etc. Terminal 1, that has 98 cubic meters. There we go, 98. And next terminal, 127, 127. And then 13. And next is 192. And last one, 214. Oh, there's a funny format there. We'll change the format there. The 4. There we go. So now, if you look at 2 grey columns, this column, that calculates the flow of the design flow rate. As you can see, the first one has 98% of the design flow rate, colored green, and you see the ones are colored black or now green means that it's quite close to the design flow rate, and the red means it's quite far from the flow rate, the design flow rate. And when one balances, it's a very good idea to have a flow which is quite close to the design flow rate, because then the method of balancing is most accurate. In the second column, you see that the message here, R and I, that means the first terminal is both reference and index terminal. Now these terms are explained in the user guide, which you can load from the AIVC website. And here we have, below that, it says 105 cubic meters per hour. And that means that the spreadsheet has actually calculated that we should throttle the terminal to 105 meters per hour. So it's already started to calculate what we'll do. So back to the second terminal, I was saying we should throttle this to 105. See if we can get something like that. Okay, so we do that. So we actually got 105. We can go back to the first terminal and check what that value is. 105. 105. And there you have it. You have. It was a very good estimate. It estimated quite accurately that 105 is the best value. And you see now, in the third row, it's saying that we should go to the next terminal and measure that. Should we do that? So we go to the next terminal, and we should measure this. It's 166. So we're not going to throttle it yet. First, we just measure it and write down the value, 166. And now, it calculates that we should throttle that to 111. So we do that. 111. Okay. Now, 2 options. What we could do, we could go back to the reference, as in drag this person back to the first terminal and measure and check that is also 111. But if we think this is okay, we'll take the risk. We think it's quite accurate. What we could do now is actually go to the next terminal and we use the third terminal as a reference. So first we're going to throttle this fourth terminal down to the third terminal. What the value is now, it's 197. So we write that 197. And the spreadsheet reckons now that it should be throttled to 113. We do that. 113. Okay. Do the same. We just go to the next terminal, measure it, 217, 217. And the spreadsheet calculates we should throttle it to 113 as well. Actually, a bit 113. say 114. Okay. It's if one wants to throttle it exactly to the value that the spreadsheet calculates, it doesn't matter. All you have to do is just to measure the value that you actually got and write the actual value that you got in the spreadsheet, even though it's different from what the spreadsheet recommends. Now, we throttle all the terminals. Shall we see what values you get for all of them? Now, we're going to draw a bar graph. And this bar graph here, the height of each bar is the flow rate through each terminal. As you can see, they are all perfectly balanced, you could say, more or less, within this price here of 5%. Now, if you have extremely small tolerance, then what would happen is that mini balance would tell us to actually calculate. If we balanced terminals slightly inaccurately, it would tell us to go back and fine-tune it in the user manual. Now, what we're going to do now is basically throttle down the fan, and they all drop down to about 100. Good down is basically just values you got. We got 101, and then was it 100, 99, and 99. Yeah. Okay. So the spreadsheet says that this is okay, and they're all very close to the design flow rate. So basically, a demonstration of mini balance using on a very small system. Now, what I want to demonstrate now is some different using the spreadsheet. If one wants to be really accurate and if one wants to be very accurate and funnel, go reference terminal, as in the first terminal in the which is furthest from the fan, and that terminal adjusts a terminal during the string. It will be rather a lot of walking to and fro between terminals. The absolutely most accurate way of using the proportional method and using millibalance. So it can be used in that way, but a good way of using millibalance, doing what I call it the chain method, you could say. You start at the end and you use the reference there to balance terminal 2, and you can use terminal 2 as a reference to balance terminal 3, and etc. So you walk basically from terminal to terminal, and it should be quicker. Or you can use any combination of those two extremes of balancing. So you can return to the reference terminal as often as you want. We have a really large system now, where you have many branches and the main duct, and the main duct also has balancing dampers. What you do basically is in mini balance, you beforehand you list all the terminals and all the balancing dampers, and all beforehand. And what you do when you actually start balancing, you can choose a random branch to balance the 4 terminals on the random branch. Let's say we want to start one of these 5 branches. So we've chosen a branch CB, which consists of 4 terminals. And what we do, in the yellow part of the spreadsheet, you just fill in the 4 terminals in the first column. So branch B, that's the second from last. That second of last branch here, which is these 4 terminals here. So we want to balance this first, say. So you just take in measurements of these 4, and then you do the normal the balancing procedure. Because you've filled in these 4 values in the first column, then the spreadsheet knows that branch CB consists of those 4 terminals. And with that, you can go to another. You clear all the yellow cells, and then you start balancing another branch. So you can balance a whole system, and you can balance the branches in any order you want. Now, when you go to the main branch, you do the same procedure. You clear all the yellow cells first, and then you balance the branch dampers. Right. For more information, I recommend you download the user and the user manual gives a number of work tables which shows different screenshots for different stages of the balancing process for different duct systems. Thanks for your attention.